Hello everyone. I am Vinayak D. Badgare from Mechatronics Department of Sri Venkateswara College of Engineering. Seminar presentation on 3D machine vision system for defect parts in automation with robotic guidelines under the guidance of Ms. Ramya P. Ma'am, Assistant Professor of Electrical and Electronic Engineering, SVC. Contents are introduction, relation between the computer vision and the image processing, type of 3D machine vision, robotic guidance, challenges associated with implementing 3D machine vision, advantages, and 3D machine vision has some limitations, including. Let us understand introduction. What is 3D machine vision? It is a technology that allows the machines to preserve the three-dimensional properties of an object, such as its shape, size, and the position in the space. This technology combines 3D sensing and the processing technique to generate a 3D presentation of the object being scanned. The 3D sensing technology used in the machine learning system can include the technology such as laser scanning, structure, light projection, the stereo vision. This technique works by projecting the pattern of light onto the object, measuring the distortion of a pattern as it interact with the object's surface. Resulting data in then processed to generate a 3D point cloud that represent the object's shape. The image processing technique used in the 3D machine vision system involves algorithms that analyze the 3D point cloud data to extract relevant information such as object dimensional surface features and the position in the space. This information can be used to guide robots or other automated systems to a variety of applications such as manufacturing, inspection, and assembly. Some of the key advantages of 3D machine vision technology includes the accuracy, precision compared to the 2D and 2D image system, as well as the ability to capture more detailed information about the object shape and the position. Additionally, 3D machine vision system can improve the productivity and quality control in manufacturing system, reduce the error and waste, and enable the work more efficient use of resource. However, 3D machine vision technology has some limitations such as computation required limited accuracy in certain situations and complexity implementation. The technology becomes increasingly important in many industries and it's expected to come for growth and evolve in the years to come. The 3D vision is a technology that enables the machine to understand the environmental in 3D dimensional, much like a human do. Obtaining the high level of understanding of an environmental from a digital image or a video. It involves the use of specialized camera and software to capture, analyze the depth information from a sense, allowing machine to accurately identify and locate object in a 3D space. To implement the 3D vision, specialized hardware and software are required. So we can see here two images. One image is of the gear and others are some parts, gear parts. Where in the first image, we can see that this image is given to a computer. This is analyzed by the processor, and the same image is used for a data extracting of then recognized image in the assembly line, where if it is doesn't match the object with the image one, then the object is said to be okay and it is sent to the further operations. If the from the second image, the any of one of the image is taken in the assembly line, it is compared to the image one. If it is not same as an image one, then it is said as a default part and it is rejected from the assembly line. For a relation between computer vision and the image processing. Computer vision and the image processing are related fields that often used together to develop advanced image-based technology. While they are related, the distinct difference in the focus and the goals are computer vision involves the development of algorithm and the techniques that enables computer to integrate and analyze the image or videos. This involves techs such as object recognition, image segmentation, and the pattern recognition. The goal of computer vision to enable the computer to understand the interrupt visual information in the same way that the human do. The image processing, on the other hand, involves the development of algorithm and technique to enhance the manipulate or analyze digital image. This can involve tasks such as filtering, noise reduction, and the color correlation. The goal of the image process is to improve the quality of usefulness of a digital image of a specific application or a task. While computer vision and image processing have different goals or focus, they are often used together to develop the advanced image technologies. For example, computer vision system may use some many image processing techniques to enhance the quality of the image being analyzed, or a image processing system may computer technologies to identify to isolate the specific feature with a image. The both fields are critical to the development of many advanced technologies such as self-drive car, medical imaging, or and facial recognition system. We can see the difference in image processing and computer vision. The focus image processor focus on the processing of the image. Both the input and the outputs are image. Here, the smoothing and sharpening will take place. Highlighting edges and the region growing will be done in the image processing. Means image processing means whatever the image is taken by the cameras is made clear with this applications. So comparison will be done. Change in brightness and contrast and watermarking will be removed, and the calibrations will be done in the image processing. In the computer processing, it focuses on making sense of what machine sees, that system inputs an image or an output task specific knowledge. On the basis of the image processing, the computer visions will task will be created by enabling identification, action, or the position or measurement or a projection. In manufacturing settings, machine vision system typically need the following: lights, lens, capture board, frame grabber, or a sensor, or a processor, and the communication. For components of machine vision system are: light eliminates the sense or object. There are different types of lightning processors, as a dark light, diffuse axial light, or a structural light, dark field light, bright lightning, and the flashing light. In the cameras, where cameras provide a lens and the sensors to capture a digital image, and the processor consists of a industrial PCs. In the processor consists of a industrial PCs, means the system on a chip with the machine vision algorithm, middleware, and the artificial intelligence for analytic and the processing. For output, the use data for the processor to direct a robot and communicate information to other machine and the software. Let explain in the lightning systems are dark light. Black light or a dark light is used to use that required border reading, improves the object counter, shape detection is added, and accuracy dimensional measurement in increasing the black illumination. For a diffusion axial illumination, the light for a left center and the optical route via diffuse the illusion light in diffusion light is reflected downwards on the section. For a semi-transparent mirror, that is lifted for the slide via the partially transparent mirror to the component reflect the light back to the camera, producing very uniformly lit and homogeneous looking image. For a structural light occurs when a pattern or a light, such as a plane grid or a more complicated design, is projected at a particular angle on it. It may be partially helpful for obtaining dimensional data, computing volume, and give construct-free surface explanation. For a dark field illumination, dark field and the bright field or a both include a bidirectional light and can disclose surface plan or more quickly. Low contrast application typically for a dark field light. The dark field light diffuses spherical light in a reflected way for a camera, where the light reflected by the surface variations and the texture is mirrored in the direction of the camera. For a lightning, the high contrast application benefits greatly for a bright field light, the high pressure sodium and the quartz light source, which are very directed and however can cast angular shadow on often to do uniformly lighting through the whole field of the view. In order to provide a equal light in the bright field, the minimizing the hot spot and the reflection on the reflecting object, and more diffuse light source many be increased. For the flashing light is used to move the items in a high speed use, so they may be explained a storm light can use to avoid burning. Machine vision system and the main components, where we can see in this image there are different components. First, the assembly line, inspection sensor, data acquisition system, detection decision sensor, programming logical control, reject keepers, and defective parts, and the application, vision application. Whenever the object is sent on the assembly line, the inspection sensor senses the object, and it sends the info signals to an acquisition system where object is coming. The signals will send to the cameras. It will take the image, it will capture the image and analyze with the stored image. And if it is any defect is found in the image, it will be rejected, or otherwise it will be, if the object is correct and match compared with the image one, then it will be sent to a further operations on assembly line. If a decision sensor will decide the part should be go for a defective part, or continue for the further operations and all, this all will be controlled by the programming logical controller. With the robotic arm, where if the defect part is found on an assembly line, it will send the signals to robotic arm. It will take the part and it will put into a defective parts, and the same data whichever the captured in the cameras and are is sent to the vision application to analyze the output. What are the default defect found in the part and all will be done in the vision application. So so let us go for each parts in details. Image capture hardware. This can include the camera, lens, light, sensors, and other equipments used to capture data or a digital image or a video. The image processing software. The software is used to analyze and manipulate the image or a video captured by the hardware. It can include algorithm for a task such of object recognition, edge detection, and the feature extraction. For image storage and retrieval, once the image or a video have to capture and proceed, they must be stored and organized for a future use. They can involve database, file system, or other storage solutions. Using user interference, a machine vision system often includes a user interference for controlling and monitoring the system. This can include a graphical use interference or a command line interference. Communication interference. In the some case, a machine vision system may need to communicate with other devices or a system. This can involve network interference, serial connections, and other communication technologies. The hardware and the software integration. A machine vision system may require integration with other hardware or software communication, such as robotic system, programming logical controller, or other automation system. Overall, the components of a machine vision system work together to capture a process and analyze the image or a video for a variety of application, including inspection, quality control, and automation. There are several types of 3D machine vision. First one is stereoscopic vision. Stereoscopic vision refers to ability of human eye to see the surrounding through the three-dimensional view with two eyes. The eyes are required to be intact and synchronized in the movement to be able to view a same object differently. The human stereo vision is capable of remarkably precise judgment, discerning the bioclonal disabilities disparities as small as 2 seconds of arc. Such performance required to good vision in the both eyes, where precision of a locomotor coordinates and the specialized sensory nerve is usually cortex. For the stereo vision, the technique used two cameras to capture the two images of an object from a slightly different angle. By comparing the difference between the two images, once the system can generate a 3D model of an object. So for we can see two images are there. For one is in a human, where we can see with our naked eyes, and using the camera. left camera field view and the right camera field view. Where it is focused on an object, it will take the image in the 3D form, where you can see in the second image the left camera image and the right camera image. The same thing, how we are seeing the same thing, the camera visualize the image and share it to the computer. In structural light, this is a technique process of projecting a known pattern or a grid or a horizontal bar of the sense. They may that forms wet sticking surface allows the vision system to calculate the depth and the surface information of the object in sense and use the structural light 3D scanners. This technique as a projection is used to project a structural pattern of an light onto an object, and the camera is used to capture the deformation of the pattern. Based on the deformation, the system can generate a 3D model of the object. Here we can see in the image the stationary target on the object. The blue light is heated on the object on the top layer. The same signal is sent and captured, and that an image is sent to the data analysis, where the data capture image will be seen as in the image. Or the light of lift, TOF. This, also known as the time of lift cameras or sensors, is a range image camera system for measuring the distance between the camera and the subject. For each point of the image based on the time of light, the round trip time of an artificial light signals and provided by the laser on an LED. This technique uses a sensor to emit a light signals or to measure a time it takes a single signal to bounce back. By measuring the time of the lift, the system can determine the distance between the sensor and the object and create a 3D model of the object, where we can see in image the light source is hitting the target and the same is received by the camera. So using this we can measure the distance of the target on the assembly line. For the laser triangulation means the distance measurement by the angular calculation. In measurement technology, a sensor projected on a laser plot onto the measurement object. Reflected light falls in incident onto a retrieving element at a certain angle depending on the distance. In this technique, a laser beam is projected on the object, and a camera is used to capture the deformation of a laser line. Based on the deformation, the system can generate a 3D model of the object. So we can see in the image the laser line of light is projected on an object under the will be tested. The projected laser line is captured by the image or camera, and that analyzed in the dictator view in the as shown in the figure. For a photometric stereo. This technique is a computer vision for eliminate the surface normal of the object by observing that object under the different light conditions. As the high quality shape eliminates a economical overhead, the photometric stereo is popular choice of a shape estimation and appearance of the capture. This application vary from 3D animation, gaming, preservation, computer assistance, surgeries to material identification and classification. This technique uses multiple image of an object captured for different light angles. By analyzing the difference between the image and the system can be generated of the 3D model of the object. So we can see in the image that there are different the images captured of the coin in a different in a four different images as shown in the figure. Let's understand in the 3D machine vision in the automation process. Some basic things are there in automation things to be known. Machine vision platform refers to software and hardware, the tools that enables the development and deployment of a computer vision application. This platform typically provide a suite of tools and libraries for image processing, machine learning, and the deep learning, as well as the interference for interacting with cameras and other sensors. There are there are some examples for machine vision platform: OpenCV, open source computer vision library; TensorFlow, TY-Torch, Cafe, and MATLAB. Let's understand them in a depth. First, OpenCV, that open source that provides tools to a real-time computer vision application. It includes a wide range of image processing algorithm, object detection, tracking, and recognition tool. For a TensorFlow, the open source machine learning platform developed by the Google. It includes a variety of tools for a deep learning, including a neural network model and algorithm, as well as the data pre-processing and the visualization. And PRTorch is another open source machine learning platform that provide a tool for deep learning. It's particularly well suitable for developing a neural network model with dynamic computing graphs. Okay, is a deep learning framework developed by the BAR. It is partially well suitable for developing the conventional neural network models and image classification and segmentation tasks. For MATLAB is a programming language and development environment commonly used for scientific computing and the data analysis. It includes a suitable tools, image processing, filtering, feature extraction, and image segmentation. These are just a few examples of a machine vision platform available. This choice of a platform will be dependent on the specific need of and requirement of an application as well as the expertise of the developers working on the project. So we can see in this video the object is picked up and the image is captured with the image is captured and then it is placed. If it is correct, it will be placed, otherwise it will be sent to an default part, and then other things will be carried out by the vision system. So same as in the previous video, this is for a electronic circuit printing, where the data is whatever the data is analyzed will be captured first only. The same image is given to an system where it is analyzed, and then on the analyzed system, it whatever element should be placed on the circuit will be first only will be decided by the user, and then that image will be given to an system that the same image is whatever the things should be placed will be taken from the robotic arms, and the same thing will be placed on the circuit, where we can see in the video. This is a complete automation process where the robotic arms are used to do such or do the operations, where the same whatever the things packing, pick and place. Complete process will be automated. A completely task will be performed by a robotic arm. Packing, unpacking, balancing, everything will be done by the robot. These are the different images taken from image processing in the 3D vision system. First, the image we can see it is a trained image. Based on this, the system will capture the parts on the assembly line. If it is in out of focus, it will show confusing background. If any background with the other thing with the image, it is in rotated in a different way. It shows in 180 rotation, reverse polarity, scale changes, occasions, same whatever the things shown in the image are taken in the 3D vision system. These are the barcode reading in a cell or a tablet broken down, that also can be analyzed in the 3D vision system. These are the spark plug. Minimum should be there in the gap in between the spark plug, that also be analyzed in the 3D vision system. Same as in the electric circuit, also got scanned and analyzed in the elbows, or whatever the degree of rotation needed, that also be analyzed in the same circuitry design. Packing of the packets also be analyzed in the image. The challenges associated with the implementing 3D machine vision: the cost, complexity, light conditions, speed, and the throughput and data processing environment factors in integration. The cost implementing the 3D machine vision system by expensive, especially with the high precious applications. The cost of the specified camera and the software on computing the hardware, and can be probability for a small or companies for others with a limited budget. Complexity with the 3D machine system can be complex to set up or operating, require specific knowledge and expertise, proper calibration and alignment of the camera light system, the accurate result which can be challenging for a non-experts. Light condition. 3D machine vision system can sensitively change the light condition which are affected accuracy and reliability of the system shadow. Reflecting on the variation ambient light can use errors in the depth sensing and object recognition. The speed and through output 3D machine vision system can slow the 2D system, especially when the processing the large amount of data. This can change the for high speed applications such as the inspection or sort where the real time analytic is required. Data processing. The 3D machine vision system generates a large amount of data that need to be processed and analyzed the real time. This requires a powerful computing hardware and specialized software, which can be expensive and complex to manage. Environment factor. The 3D machine vision system can affect the environment factors such as temperature, humidity, and the vibration. This can cause inaccuracy in the depth sensing and the object recognition, especially in the harsh industrial environment. And the integrating the 3D machine vision system, expensive machineries and automation system can be challenges, especially when the working with the large legacy equipments. Compatibility issues, communication protocol, and software integration can be also potentially roadback to a success. Applications of 3D machine vision, quality control and the inspection, robotic and automation, object recognition, medical images, virtual reality, and gaming and agriculture. Quality control 3D machine vision can be used for quality control and inspection manufacturing industries such as automotive, aerospace, and consumer goods. It is a quick, accurate defect parts and such scratch dents and the surfaces, irregularities, and the complex parts are assemblies. Robotic automation. The 3D machine vision is essential components for a robotic automation system, enabling the robot to identify the located object in an environment and perform a task with greater accuracy and precision. Object recognition. The 3D machine vision can use for object recognition classification of applications such as autonomous driver, securities, and the survival. It can identify the based on the shape, texture, and even in the challenging light and environment. Then medical, it is used for a CT scan, MRI, for such examples as a tumor and internal bleeding. Virtual reality, the this is for your virtual reality gaming applications such as creating impressive environment, interactive expenses, tracking the position and movement of the object in the people in a real time, enabling user to interact with digital content in a more nature and immersive way. And for the agriculture, for we can use agriculture applications such as monitoring the crops growth health, and it also capture the 3D image crops, analyze them to detect analyze disease, nutrient deficiency, and other issues, enabling farmers to protect measurements to improve field and reduce the waste. Machine learning vision has some limitation including computational requirement, limited accuracy, limited range, limited speed, limited field of view, and complexity and the setup. For complicative and for a computational requirements, the resource and the powerful resource of the high speed graphic card to be processed for a large amount of data in the real time. This makes a system expensive and complex in implementing. Limited accuracy for a complex shape and counter. The accuracy system also be impacted by challenging light condition on the reflective of the surface being scanned. In the limited range, the automotive manufacturing, the machine vision may not be able to capture the entire surface of the object in a single scan. For a limited speed, the 3D and the 2D and 3D images, they make unstable for application required high speed data capture. For limiting the data field of the view, this can make the challenges to capture the complete 3D model of an object or a complex object. Complexity of the setup. Implementing a 3D machine vision system to required specifies for image processing and 3D modeling. This can make the challenge the organization to adopt the technology, particularly smaller business with a limited resource. Thank you.